Alright guys, this is still lesson 1, but part 2. So we finished up in the last video just talking kind of about exact form and having square roots in that. So let's practice that a little bit. This one says to round your answers to the nearest tenth if necessary. So again, here's my right angle notation. It's pointing to my hypotenuse. So x is basically c in my Pythagorean theorem. So I'm going to take my 6 squared plus 8 squared. I could do 8 squared plus 6 squared. Doesn't matter. Again, I could just rotate this triangle, and it's going to equal my x squared. Remember, that's just like my c. So 64, oops, that's 64 plus 36. Just my little brain wanted to go in 2 different directions there. So when I add these together, I get 100 equals x squared. Take the square root of 100 will equal x, and 10 equals x. I don't have to do any rounding there. If you recall from our last lesson, I've got a 3 and a 5. My hypotenuse, this is my c. So if I take 3 squared plus x squared would equal my 5 squared. 9 plus x squared equals 25. Subtract 9 from both sides, and x squared equals 16. So x equals the square root of 16. X equals 4. We're going to say both of these are in little units because we're discussing a length. All right, let's take a look at this one. Again, this is my c value because it is my hypotenuse. So x squared plus the square root of 14 squared equals 4 squared. So x squared, if I take the square root of 14 and I square it, that's the square root of 14 times the square root of 14, which would end up being 14. Subtract 14 from both sides, x squared equals 2. X equals the square root of 2. This is exact. It says leave your answers in simplest radical form. That means exact form. We are not estimating. We're not going to a decimal value. This is anytime you have an imperfect square, then you're gonna the exact form is the most precise. Here's my right angle. It points to my hypotenuse, which is making this my c. So I would have my x squared plus 14 squared equals 15 squared. All right, so now we're going to take our values, and I have x squared plus 196 equals 225. Subtract 196 from both sides, and I get x squared equals 29. Now, I have been just jumping to x equals the square root of, but really what I'm doing is I'm taking the square root of both sides. Just trying to show you. These are like opposite operations, just like how addition and subtraction cancel each other out. Multiplication and division cancel each other out. Squaring and square rooting cancel each other out. So x is exactly equal to 29 root 29 units. Okay, so now we're going to get into some right triangle trig. Okay, don't let this scare you. And guys, we are focusing on right triangle trig. There's lots of trig ratios out there, but we're only going to talk about the ones that deal with right triangles. Angle of interest. So let's start off with a right triangle. Terrible right triangle. If I put a theta here, that's what that is. That could be an angle of interest. This is what I'm going to label my angle off of. I'm going to arc my angle of interest. You might also see it, your angle of interest. You might also, let's say, just have an X in it. I would arc that as my angle of interest. And so angle of interest is what we're going to label the triangle off of. Sometimes there's a question mark there. That's what I'm going to arc as my angle of interest. And the other thing is that you might have actually some degrees you're working with. That could be my angle of interest. You have to look at the problem to decide. Now the other thing I want to talk about here is if you've got a right triangle. Remember, all triangles, the sum of all angles, equals 180 degrees. Well, let's just say this is angle 3. Just for argument's measure angle 3. That means that our other angles, the measure of angle 1 plus the measure of angle 2, always equals 90 degrees. So measure of angle, or I'm just going to say, angle 1 and angle 2, your acute angles, are always complementary. Which means they add up to 90 degrees right here. So if this is theta, or our angle of interest, then this one's going to be 90 minus theta. If this is x, this is 90 minus x. I've got a question mark here. This one is 90 minus my question mark. And if this is 39 degrees, then this one is 90 minus 39. Okay, so let's talk about labeling. HOA. Now, when we start labeling our sides, H stands for hypotenuse. And that is always across from the right angle. O stands for opposite. A stands for adjacent. Opposite and adjacent to what? To the angle of interest. Which, by the way, is never the right angle. It's never your angle of interest. Okay, so when I'm looking at this one, I'm going to arc my angle of interest. Okay, so if I'm going to go across from the angle of interest and this one is opposite, notice that this side right here does not touch the arc anywhere. Well, here's my right angle notation. It's pointing to my hypotenuse, leaving this as my adjacent. Notice my adjacent side does go through where I've arced my angle of interest. So when I look at it and I arc, there's my hypotenuse. The other side of the arc is my adjacent. There's my opposite. Arc, here's my hypotenuse that angle's pointing to. The other part of the arc goes to the adjacent and opposite. Arc, there's my hypotenuse. The other side of the arc is my adjacent. There's my opposite. It becomes very important to be able to label your triangles, because this is where, this is a trick question, this is where all of our right triangle trig ratios come from. So now we've got our angle of interest here, and so this is not what we can do. We cannot label our angle of interest as our 90-degree angle. Here I've got my angle of interest. This is pointing to my hypotenuse. The other side's adjacent and opposite. Always arc your angle of interest. Points to the hypotenuse. There's my adjacent and opposite. Arc the angle of interest. Points to the hypotenuse. Other side of the arc goes through the adjacent, touches it. There's the opposite. 90 degrees across from that is my hypotenuse. I know it doesn't look it, but it's been labeled. There's my adjacent and my opposite. Arc your angle of interest. Hypotenuse, adjacent, opposite. Okay, let's think about this. This is 30 plus 50 is 80. That's 90. That makes this a 90-degree angle. Cannot be an angle of interest. Here's my angle of interest. Points to my hypotenuse, my adjacent, opposite. Angle of interest. Okay, points to the hypotenuse, adjacent, and then opposite. Now the one thing I want to tell you about here is, let's say we're working with this triangle. And we've got our 60-degree angle here. We know this is our 30-degree angle. And they're telling you that the 30-degree angle is your angle of interest. Well, then this is how you label your triangle. But if the angle of interest changes, if they say, nope, now I want to focus with the 60-degree angle. Well, now the hypotenuse, you see, does not change positions. It's in the same position. But now my adjacent is down here and my opposite is there. So if your angle of interest changes on the same triangle, you have to relabel it for your problems. Okay, guys, that's the end of lesson 1. I'll see you in lesson 2.